Hello everyone,
CMC Solutions の青田さん
I'm
と申しま
Aozasa
す。
from CMC
本日はよろし
Solutions.
くお願いいたします。それでは早速本題に移ります。
So I'd like to start my presentation. So development of visual programming tool SIMD for IoT devices, achievement report of the human resource development with the local community is my presentation title. So again, my presentation. So my name is Seiya Aozasa from CMC Solutions. I joined this company this year and now at the Matsue office. I graduated from Matsue College of Technology this year, and I'm from the last year, and I'm going to present what I did as a graduation thesis. The first little bit of background of this project: I had an IoT class at school, and we used Raspberry Pi to measure the ambient temperature and put the data into the graph. It was interesting, but it required a lot of knowledge about information or IT, so quite challenging for a beginner. So I thought it would be nice to have some IoT learning package, easy to use even for absolute beginners. There are microbit, make code, and the like to do a kind of IoT with visual programming. But after that, applying the experience to move to more general embedded programming to operate a microcomputer is a difficult task. So I thought of making visual programming tool that allows a mutual conversion between blocks and source codes to operate a microcomputer. If we use small Ruby, a Scratch-based software, C Ruby source codes and Scratch blocks can be converted to each other. I thought of modifying small Ruby so conversion would be possible with mruby/C, lightweight Ruby instead of C Ruby. But at that time I was still a student. I did not have knowledge of small Ruby, mruby/C, or how to implement them. And the Matsue College of Technology has the Ruby Human Resource Development Community. I belong to that community, so I could learn basic programming and did the development of SMT or SIMD with members of the community. This Ruby Human Resource Community is a part of public-private academia collaboration supported by Matsue College of Technology, Shimane Prefecture, Matsue City, local industry, and NPOs to develop Ruby engineers. For example, this community offers Ruby seminars after class hours, teach embedded system at class, or learning experience about Ruby, development of small Ruby at the college. Let me share my experience of the project in this community. First, I learned about small Ruby. Luckily, the leader of Ruby programming use team, Takao-san, was a developer of small Ruby, so I could learn how to generate blocks to do programming and program conversion from him. Also, this use team supported the verification phase of the project as well. Regarding mruby/C, Shimane Software Research Center, iTalk, and Monster Lab were tremendous help, providing development environment and teaching basic programming. As presented at the Ruby World Conference last year, the community has a project to use mruby/C during the class at Matsue College of Technology, and a Monster Lab kindly shared the mruby/C library they developed for ESP32 microcomputer. So now about this project, the package flow. We write codes and build blocks using small Ruby with added blocks for microcomputer, such as acquiring temperature data from thermal sensor and send it to server. Next, these blocks are converted to mruby/C source codes, which are compiled and written to microcomputer board. So up to this step is the job of SIMD. On server side, we use the service called Ambient to visualize data. This is how the screen looks for SIMD, which is, by the way, a Windows application using Electron. So on a back end, WSL is operating and the programs are compiled, transferred, executed in ESP32 microcomputer development environment called ESP-IDF. Red block on the left is a block added this time. You can control input-output of LED, LCD monitor, a slide switch, and also HTTP communication with Wi-Fi connection by combining blocks. As we have a simulator on the right, we do not have to compile and transmit the program every time, as we can check how it would behave on the simulator. It works with on and off of LED and switch. Using right button on the menu bar at the top left, we can make microcomputer board connected to USB port to perform compilation, transmission, and execution of the program. This is the board we used. It has ESP32 chip, and that was made at our school. ESP32 is the chip mounted on the famous M5 stack. Adding HAT for extended capability, it can be connected to general-purpose sensors such as I2C. Now, I will tell you how we did a verification experiment of SIMD. First experiment done by Ruby programming use team. We asked them to try SIMD at their coder dojo. This time, no server connection. Participants, elementary school kids, worked on embedded programming to the board only. They made 3 programs. 1, a program to turn on off LED light. 2, making a sound with switching on and off, also showing switches on, switches off on the monitor. They're putting out the character strings, the branching program. The 3, a microcomputer board has 8 LED lights. Turn them on one by one, and when all of them are on, there will be a sound notifying success, the kind of slot game program. And we also did the questionnaire about SIMD. Here you see the results. All participants successfully completed all 3 programs. So we can say even an elementary school kids could learn embedded programming using SIMD. As for the questionnaire, the many responded they enjoyed using SIMD, and they said they wanted to join next time too. And I noticed some kids continued coding with SIMD even after the experiment was over. So the experiment showed that SIMD can raise the interest in embedded programming, which is the step before IoT. Next is the experiment we did at Matsuya College of Technology. 4 students in their first year joined. This time, whole package was tried, including server transmission. There were 2 assignments. 1, turn on and off LED light depending on the switching condition with conditional branching program. 2, send the temperature data captured by the temperature sensor to ambient. So this time we wanted to see the usefulness of SIMD. So we compared 2 scenarios, the one using SIMD for programming and execution to no SIMD, directly writing programs with mruby/c, the writing the command in development environment to execute the program. And all participants tried both. And for mruby/c, some sample codes necessary for implementation were provided. And we measured the time required from the starting program to obtain the expected results. We also did the questionnaire about SIMD, and this is the result. So as you see in this graph, 1, LED switch program with conditional program, the branching program, not much difference. But number 2 shows a bigger difference. It's the program sending temperature data to ambient, and total time was shorter by 20 minutes on average when students had a chance to, students could use SIMD. We assume that with bigger program, more code writing required, there's more chance of grammar error and typos. So using SIMD, you can concentrate on logic rather than wasting time due to careless mistake. Here is the questionnaire results. 3 out of 4 students said a SIMD made programming easier. And regarding the understanding of codes, some said they could understand the role of each code, meaning or parameter values and so on, because of the mutual conversion with blocks. So based upon these feedback, we think SIMD makes technology less challenging for beginners to learn IoT. Now conclusion. We could conclude that SIMD, jointly developed with Ruby HRD community, provided and make IoT more accessible, and its educational package beginners and children without the knowledge of IoT can enjoy. The remaining issues include introduction cost and requirements of specific microcomputer board, so further improvement is necessary. What am I doing now? With support by our company CMC Solutions, I participate in Ruby Club as a mentor together with Fujihara-san, a former club member and a graduate of the college. I was a student in a community, and now I am teaching in a community. It is good about Ruby human resource development community, where those who studied in the community would become instructor and teach a junior. So it's a very good cycle. As for SIMD, the students and some other members continue its research and development. This year, Satsuki Okuda studied the use of SIMD for in-process quality inspection at manufacturing company as her graduation thesis. What she did was to modify SIMD so inspectors with limited knowledge of programming can generate and modify quality test codes. This was also a joint project with Nippo, a local company, and Shimane Software R&D Center. Another project ongoing is to use SIMD for R-board. R-board is a board for PIC32 microcomputer and now developed by Shimane Information Process Center. It is welcoming as now SIMD can use only ESP32 microcomputer board. Also experience of SIMD development developed a unique mruby/C community. ESP32 and the PIC32 mruby/C libraries are well developed by those who are in Ruby human resource development community. And the number of commits is increasing too. I hope the community would further grow and produce more Ruby engineers, including ones for mruby and mruby/C. This concludes my presentation. Thank you very much.